Welcome back. We are talking trigonometry as our topic, and we are discussing trigonometric ratios of 30 degrees and 60 degrees. I said consider, and we ended here. We are considering an equilateral triangle of side whose magnitude is 2 units. Remember, if it is an equilateral triangle, all its sides are equal and all its angles are also equal. Okay? So if one side is 2 units, that means even the other is 2 and the other is also what? The other is also 2. And now, I can divide this into 2. Remember, I want to form a right-angled triangle somewhere so that I can use my Pythagoras theorem properly. If this side is of 2 units, that is from one end up to the other, that means if I draw this line from up here, it will meet the middle of this line. That means this is a 1, and this one is also a 1. And that one is also a 1. Now, I can extract something like this. I can extract something like this. An angle of 60 degrees there. I have a 90 degrees there. Since I've divided here, this one cannot remain a 60. It will become what? 30. So I have a 30 degrees there. Here, I have a 1. This is a 2. I'm lacking a certain value here for me to deal with what I want. So if I call this B, I can say that from A squared plus B squared, this one is equal to what? C squared. That is the Pythagoras theorem. Now, if this is 1 squared, I don't have B. This is 2 squared. So 1 squared is 1. This is B squared is equal to 4. When you square 2, you get 4. B squared will be equal to, if you take the one the other side, you get a 3. And the value of B is the square root of what? Of 3. Remember, we are dealing with the sides. Someone may ask why not plus or minus. We don't have negative length. We are dealing with the sides. This is root 3. So if that is root 3, I can from there determine what I want. Our subheading is talking about the trig ratios of 30 and 60 degrees. If I start with 60 degrees, I need to determine sine 60 degrees. So I've got this as root 3. So from what we saw, we discovered that sine is opposite over hypotenuse. So if it is opposite of 60, or the opposite side of 60 is root 3 over the hypotenuse side, which is a 2. Then we can talk of cos 60 degrees. Cos 60, we have cos is adjacent over hypotenuse, and that is none other than a half. Then we have tan of 60 degrees. This one is tan is opposite. Tan is opposite. Remember, Toa. So it is opposite, which is root 3 over 1. So we can just, it is opposite over adjacent. So it is root 3. The adjacent side is 1. Or I can just put it as root what? Root 3. So these ones should be at your fingertips because I've just verified where they come from. Then if I'm to talk about the sine of 30 degrees, sine 30, I'll come back here. Now 30 is up here. You have to be very keen. 30 is where? 30 is here. The side opposite to this angle is 1. So it will be 1 over the hypotenuse side. Then cos of 30 degrees, the side adjacent to this angle 30 is of magnitude 3 units over the hypotenuse side, which is 2. Then when we talk of tan 30 degrees, that one is going to be tan. We've said it is opposite, so tan 30 we have opposite, which is 1 over the adjacent, which is root 3. Actually, it is from here that you can also take a note and say that tan of any angle, theta represents any angle. It is sine theta over cos theta. If you divide this by this, you'll come to what we have there, or if you do what we have there. Now, this one is the trig ratios of 30 degrees and 45. We have looked at cos of 30, sine of 30, and tan of 30. We have also looked at the sine of 60, cos of 60, and tan of 60. Then we can also look at the trig ratios of 45 degrees. So what we are going to do with this, we are going to consider a square of magnitude. Now it should be square of the side of magnitude 1 unit. Now, we all know features of a square. We all know features of what? A square. Features of a square is a four-sided figure with all angles equal and sides equal. Then secondly, since it is a four-sided figure, the total angle sum of that figure is 360 degrees. So if it is a square and it is a four-sided figure, they have told us we have 1, 1, 1 there. So this is 90, this is 90, this is 90, and that is 90. If I draw a diagonal from one corner to another, I'll end up with something like that. And with that case, if I extract a right-angled triangle from there, I have something like this. With a 90 here, now this one is 45 degrees because I've divided the 90 into 2. Even this one is 45 degrees. This one is 1, and also that side is 1. We are lacking the hypotenuse what? We are lacking the hypotenuse side. So from a squared plus b squared, which is equal to c squared, this is 1 squared plus another 1 squared, giving you a c squared. 1 squared is 1, another 1 squared is 1. This is c squared. So c squared is equal to 2. And the value of c is the square root of what? 2. So therefore, that is root 2. So we are talking of the trig ratios of 45 degrees. That means we need sine 45. Sine 45, we have opposite of this angle, even if we use this because we have 45. So 45, we have opposite is 1 over the hypotenuse. Cos of 45 degrees, this one is also 1 over root 2. Okay? And tan 45 degrees, this one is what? 1. Why? It is opposite to this 45 is 1 over or divided by the adjacent, which is also 1. So 1 over 1 gives you a 1. 1 over 1 gives you a 1. After learning this, it is no longer hidden secret that the cosine, sine, and tan of 30, 45, and 60 are always known ratios. The word ratio shouldn't confuse you. A ratio, some of you are used 1 to 2, it is only a ratio that you know. No. If you rewrite this as a fraction, it becomes what? A half. Okay? So that's why we are having this fraction or these fractions all through. So the trig ratios of 30, 60, and 45, they are now at our fingertips. From your calculators, for instance, if you press sine 60 degrees, the calculator will give you 0.866 and so on. If you get this value and divide it by, in other words, if you get root 3 and the value of root 3 on your calculator and you divide it by 2, you will still get 0.866 and so on. If you get, for instance, sine of 30 degrees, always the calculator has been giving you a half. But where would that half be coming from? It comes from there. It comes from there. Okay? So, after that, can we talk about trig ratios of other angles? Now, we've talked of 30, 45, and 60. We've talked of 30, 45, and 60. We have all those three that we've talked about. Fun enough, they come from one region because they are all acute. How about other angles? What if they ask you for the sine of 210 degrees? What if they ask you for the cosine of 150 degrees? Eh? What if they ask you for the tan of 330 degrees? Are you going to leave that hanging? No. That's why we need to also talk about others. We need to talk about what? Others. Now, from our quadrant or quadrant C, it is 0, 90, 180, 270. If I complete a full turn, that is 360. Now, I'm bringing in another interesting one, but very easy. In the first quadrant, remember I've said that this is the first quadrant. In the first quadrant, all trig ratios of angles here, A stands for all. All the trig ratios of angles in the first quadrant are positive. In the second quadrant, we have letter S. S stands for sine. Sine here means in the second quadrant, it is only the trig ratios of sine that are the angles in line with the sine will give you a positive. The rest are negatives. I repeat. In the second quadrant, it is only sine of the angles here that gives the positive value. The rest will always give you a negative. What does that mean? Angles between 90 and 180 degrees, because in the second quadrant, so the angles you find there, they will always generate for you a positive value if you press their sign. The rest will give you a negative. In other words, for instance, if it is sine 150 degrees, sine 150 degrees here will give you a positive value. But cos 150, remember 150 is also in the second quadrant, that one will give you a negative value. In the third quadrant, we have letter T. Here, it means that the tan of angles in the third quadrant is positive. Sine and cos are negatives. In other words, for instance, if I take on 240, sine of 240 is negative in the third quadrant. Sine of, okay, I can also use 210. Sine of 210 degrees is also negative here. We are talking of angles between 180 and 270. But the tan of 210 or 240, or that one gives you a positive value. Lastly, we have C. This is in the fourth quadrant. That is in the fourth quadrant. There, the cosine of angles here is positive. The rest are negatives. When I talk of the rest, we have sine, tan, and cos. So if I talk of sine being positive, that means the sine of angles in the fourth quadrant and the tan of angles in the fourth quadrant will generate for you a negative value. They will generate for you a negative value. So I can still draw another quadrant. I can draw another quadrant and put it in a more mathematical perspective. I can put it in a more mathematical perspective. For instance, if I have angle theta, let me start with theta. Theta is in the first quadrant. Sine theta is positive, cos theta is also positive, and tan theta is also positive. In the second quadrant, if I have angle alpha, sine of alpha will be positive, but cos alpha, this one is negative, and tan alpha is also what? Negative. Basing on this together. Then when we go to the third one, I can talk of angle beta. Here, sine of beta is negative, cos of beta is negative, then tan of beta is the one which is positive. Why? Because of this. Then when I go to the last one, or the fourth quadrant, I can talk of an angle there as gamma. So sine of gamma is negative, cos of gamma, this one is positive, and tan of gamma, this one is negative. As you can see, all that information is trying to demystify, it's trying to ensure that what I've written here makes some sense. I want to remind you that we have 0 degrees, we have 90 degrees, we have 180 degrees, we have 270 degrees, and 360 degrees. So angles between 90 and 180, they are only going to give you a positive result if you press they are saying. We are going to continue from there.